So this is Saxon Algebra Test 11. Number 1 says Ron is renting a car for 5 days. I'm going to go ahead and underline that because that seems like that might be important. He can spend $200 at most. There is a deposit fee of $50. What can he spend at most on the per day rental fee, including the $50 deposit? So this is what we're trying to find, what he can spend at most on the per day rental fee. So let's go back to what we know. We know that he has to put down an initial pot deposit of $50. So no matter what, he has to pay $50. But in addition to that, he has to pay some amount of money per day. Well, we know that he's going to be renting it for 5 days, but we don't know how much he's paying per day. So that's going to be our variable. So we're going to, in addition to that $50, he has to spend some amount of money for 5 days. And now he wants to spend at most $200. So that means whatever he spends right here needs to be less than or equal to $200. Because if he wants to spend at most $200, he does not want to go over $200. So now we have our equation set up and we just use algebra to solve. So since we want x by itself, I'm going to first get rid of this 50 by subtracting it from both sides. So we're left with 5x is less than or equal to 150. And now divide by 5. So we get x is less than or equal to 30. And we're talking about money, the fee that he's going to spend per day. So it's $30. So he can spend at most $30 per day for that rental fee. Number 2, the box and whisker plot shows scores for a basketball team. Use the interquartile range to identify outliers. All right, so there is a formula we need to use to find the outliers. So one is, we say x, anything less than quartile 1 minus 1.5 times the interquartile range. So that'll give us any data that falls below over on this side is going to be an outlier. We need the interquartile range first. So we find the interquartile range by doing quartile 3 minus quartile 1. Because remember, we know range means you subtract the largest from the biggest, but in this case, we're subtracting the biggest quartile minus the smallest quartile. So here is your quartile 3, and here is your quartile 1. So it looks like it's 80 minus 60. So our interquartile range is 80 minus 60, or 20. So now let's go and plug in some of this information into our formula. So again, we have x is less than quartile 1, which we said is 60, minus 1.5 times our interquartile range, which we just said was 20. So we have x is less than 60 minus 1.5 times 20 is going to give us 30. And then I'm going to move this up here just so it doesn't get cut off. So we have x is less than 60 minus 30 is 30. So that's saying if there's any data that is less than 30 on our box and whisker plot, it's an outlier. But if we go up and look, here's our smallest piece of data, which is 50. So we don't have anything less than 30. So there isn't an outlier on the small end. Now let's find the other outlier, or see if there's an outlier on the greater side of the data. So this formula is x, we want any x value greater than quartile 3 plus, so notice it's plus this time, 1.5 times the interquartile range. All right, so now let's go start plugging in our info. Quartile 3 we can see is 80 plus 1.5, and we already found the interquartile range is 20. Let's put that there. So we have x is greater than 80 plus, and we already calculated this with the other formula. We know that's 30. So therefore, x is greater than 110. So notice our biggest point is right here, which is, it looks like it's a little less than 90. So we don't have any data that's greater than 110. So for this problem, there are no outliers. Number 3, we have to simplify this and, if possible, identify any excluded values. So remember, excluded values means you can never have a denominator equal 0, because if you do, it's undefined. So the easiest and fastest way to find any excluded values is to take your denominator, which is 8x, and set it equal to 0. Because we want to see, well, what would x be to make our denominator be a 0? Because whatever that number is, we don't want it, because we don't want our denominator to be 0. So now we just use algebra and we solve for x. So x equals 0. So if x were 0, then our denominator would be 0, which makes sense, because if we plugged 0 into this x right here, 8 times 0 would be 0. So we would say our excluded values, or x cannot be 0. Now let's go back, and because we still have to simplify this problem. So I'm going to rewrite it over here. So we have 2x squared over 8x. So I'm going to do the numbers first. 2 over 8. Well, we can divide both of those by 2 to get 1/4. Now notice we have an x squared on top and an x on the bottom. So this x will, well, with our rules for exponents, we subtract the exponents since we're dividing. So 2, and this is really a 1. 2 minus 1 is 1. So this 1 cancels out, and we're just left with an x here. So in simplified form, since we really don't need that 1 in front of the x, I would rewrite this as x over 4. Okay, number 4, the following data shows scores for a math test. Identify any outliers. What is the effect of any outliers on measures of central tendency? Okay, so we have to put these in order from least to greatest. So we have 65, 68, 69, 70, 71, 72, 75, let's see, 83, 83, and 98. So there they are in order from least to greatest. So first, in order to find our outlier, we need to know our mean, our median, and then we also need to find our quartile 1 and quartile 3. So I think it's easiest just to kind of make a box and whisker plot for this, because you can visually see where quartile 1, quartile 3 is. So let's first find our median. So we have 1, 2, 3, 4, 1, 2, 3, 4. So it looks like 71 is our median. So that means our quartile 1, we have to find the median of the lower data. So notice we have 2 pieces of data in the middle. So it's going to be halfway between there. So our quartile 1 is halfway between there, which is 68.5. So I'm going to write that right here, because that's our quartile 1. And then we need to find the median of the upper data. And again, it's right here in this piece of data. And the middle number of that, if you add 75 plus 83 and divide by 2, you get 79. So if we were making a box and whisker plot, this would be our box, and this is our quartile 3, and this is our quartile 1. And then we have our extremes, which is 98 and 65. So we just made our box and whisker plot. So what they want us to do is identify the outliers. So remember, to find an outlier, you need your interquartile range. So our interquartile range, which is going to be quartile 3 minus quartile 1, or 79 minus 68.5, which comes out to 10.5. Okay, so I'm going to erase some of this right here just so I have room, because we now need to go and find our outliers. So let's do the small side first. We have x is less than quartile 1, which is 68.5, minus 1.5 times 10.5. So this is 68.5 minus 1.5 times 10.5 is going to give us 15.75. And now when we do the subtraction, we get 52.75. And notice our lowest number is 65. We don't have anything less than 52.75. So there are no outliers on this end. Now let's do the other side. We have x is greater than quartile 3, which is 79, plus 1.5 times our interquartile range, which was 10.5. So we have 79 plus, we already figured this out, that's 15.75. And when we add those two together, we get 94.75. Now, if we look at our data, we do have one number that's bigger than 94.75, and that's 98. So we have one outlier in this case. So our outlier is 98. The second part of this question wants to know what is the effect of any outliers on measures of central tendency. So I'm going to erase everything we did here. So to find the effect of outliers on measures of central tendency, we need to compare the mean, the median, and the range with and without the outlier. So sometimes it's easy just to kind of set up a chart like this. We have mean, median, and range. And we're going to calculate all this first with our outlier, which is 98, and without 98. And we're going to compare and see how it affects these three measures of central tendency. So again, putting these in order, I'm going to write this again since I erased it. All right, so that's our data in order from least to greatest. Notice I included 98 because we're going to find everything with our outlier. So the median we already calculated early. We know that was 71. The range is just 98 minus 65. So 98 minus 65, and we get 33. So for our mean, we have to add up all of the data and then divide by however many pieces of data there are, which is 9. So if we add all that up together and divide by 9, it comes out to 75. Okay, so that's all of our measures of central tendency with the outlier. Now, if we were to take this outlier out and recalculate all this, we're going to see how it affects it. So the mean without the outlier, we have to add all of those together, and then this time we only divide by 8 because now we only have 8 pieces of data. And that comes out to, let's see, it's going to be a decimal, so 71.625. Now the median is also going to be different because we have 2 pieces of data in the middle, so it's going to be 70.5. And the range is obviously going to be different because now we're doing 83 minus 65, which is going to give us 18. So I would write that it raised the mean, the median, and the range. So our outlier was 98, and it raised our mean, median, and range, but had no effect on the mode. Number 5, simplify. So remember, this is a power raised to a power, so we need to distribute this exponent of 3 to every single thing in our parentheses. So we have 2 cubed, and then we have x. Now remember your rules. When you have a power raised to a power, you multiply. So that's 3 times 3 is x to the 9th. And then we have y. This is really y1. So 1 times 3 is 3. Not quite done yet. We can still simplify the 2 to the 3rd. So our final answer is 8x9y cubed. Okay, this one is just combining like terms. So if you want to, you can go ahead and go in and change these 2 subtraction signs at the end. You can add a line, change a sign, and then add a line, change the sign. And then I usually like to just start from the left. Notice we have 2x cubed. I then go and look and see if there are any other x cubes that I can combine that with, and there is. So we have 2x cubed plus a negative 3x cubed, which will combine to give us a negative 1x cubed. Then I go and look at my next number. It's y squared. Notice that there aren't any other y squareds, so there's nothing to combine it with, so it just stays 3y squared. Next, I have this x cubed y squared, which is the same as right here, so those can be combined. So it's 4 plus a negative 2, so that becomes plus 2x cubed y squared. Simplify. So this one we need to distribute this x3 over y to both pieces of fractions in the parentheses. So let's start with the first fraction. So we have x3 times y squared. Those can't be combined, so we just write them like this. And now let's do the denominators. We have y x squared plus, and now we have to distribute it all to the second fraction. So we have 2 and then x3 y3 all over yx. Now that's just the first part. Now we have to go and see if we can simplify anything. So let's look at the first fraction. We have x's on the top and the bottom and y's. So notice that there's x3 on the top and x2 on the bottom. So this x2 will cancel out and this becomes a 2. So I'm going to start rewriting it over here, my final answer. And then we have a y squared, and just a y to the first. So when we subtract 2 minus 1, that just gives us y1. So notice everything is gone from the denominator. And then we're going to add, over on this side, we have our 2. There's nothing to cancel it out with it on the bottom. Now let's do our x's. We have x3 on the top and x1 on the bottom. So if we do 3 minus 1, that leaves us with just x2 on top. And we know that it remains on the top because there are more x's on the top than the bottom. And now let's look at the y's. We have y3 and y1. So again, 3 minus 1 gives us y2. And again, everything canceled on the bottom. So we have no denominators anymore. So that is our final answer. Simplify. We have 1 over into the negative fifth. We never want to have negative exponents. And the easiest, simplest way to get rid of a negative exponent is to just switch it, and if it's in the denominator, move it to the numerator, and vice versa. So in this case, since n to the negative fifth is in the denominator, I'm just going to move it up to the top, and the exponent becomes positive. And so there's nothing left on the denominator, so this is just our final answer, into the fifth, into the positive fifth. Number 9, write the polynomial 3y squared plus y cubed in standard form. Then write the leading coefficient. So standard form, when you're writing polynomials, means you have to have it in order of the exponents descending. So you want to have your greatest exponent first and then them descending. So notice that this is y3 and this is y2. So this one right here should be first because it has the bigger exponent. So that should be y3 plus 3y squared. Notice I'm not putting them in order by the coefficients. I'm just putting them in order by the exponents. So that's it written in standard form for a polynomial. Now they want us to write the leading coefficient. Remember, coefficients are the numbers that are in front of the variables. And the leading coefficient is just the very, very first coefficient. So our very first coefficient is right here in front of that y, which is a 1. So 1 is the leading coefficient. I'm just going to leave it like that. Leading coefficient is 1. Number 10, determine the slope of the line that contains the points 3, 7, and negative 2, 3. So remember, we just want to use our formula for slope, which is we find the difference in the y values, and we divide that or put that over the difference in our x values because we're finding the rise, how much it goes up or down the y-axis over the run, how far it goes left or right over the x. Now, it doesn't matter which y you choose to start with. So I'm going to choose to start with the 7, and then I'm going to subtract the other y, which is 3. Now, this part does matter. Since I chose this y to begin with, I have to choose its partner x to begin with. So I have 3 minus a negative 2, which really just becomes plus 2. So we have 4 here over 5. Now remember, with slope, you don't want to write this as a decimal or anything like this because that clearly shows 4 is your rise and 5 is your run. So you would leave your answer as a fraction, 4/5. Number 11, tell whether the ordered pair 2, 4 is a solution of the system below. So remember, in order for it to be a solution, it has to satisfy both of the equations. So what we need to do is plug this point into both of those and solve and make sure we get a true equation. So let's start with the first one. I'm going to plug in 2 for my x minus 2 times 4, because that's my y, equals negative 6. So we have 2 minus 8 equals negative 6. So that's negative 6 equals negative 6. All right, so that one worked. However, we still have to do the second one and make sure that one works too. So we have 3 times 2, because that's our x, plus 2y, which is 4, equals 12. So this is 6 plus 8 equals 12. Well, this gives us 14, which does not equal 12. So no, this is not a solution because it only satisfied one of them, but not both. Write the equation of the graphed line in slope-intercept form. So remember, slope-intercept form, you need the slope and you need the intercept. And it's written as y equals mx plus b, where b is our y-intercept and m is our slope. Now the y-intercept, we can see pretty clearly, it's right here, and that's at 1. Now the slope, we need to figure out what it is. Now here are 2 pretty clear points. You could use your slope formula and find the slope there, but it's kind of easy to see what it is right now. Now notice though that my line is going downwards from left to right, so I know my slope is going to be negative. And if we look, it goes down 1 and then over 2. So my slope is negative because it's going downwards, my line, and it went down 1 and then it went over 2. And then we keep x plus 1 and then put our y equals. So we found our slope and we found our y-intercept. And those are the only 2 pieces of info you need to write in slope-intercept form. All right, number 13. A shipping carton in the shape of a cube has a volume of 64 cubic feet. What is the side length of the carton? So remember, a cube, all of the sides are the same. So the length, the width, and the height are all the same. So when we found the volume, we did x cubed, because they're all the same, equals 64. So we're basically trying to figure out what number times itself 3 times is 64. Or in other words, we're trying to find the cubed root of 64. So unless you know this off the top of your head, you might have to play around with a few numbers. But it is 4, because 4 times 4 times 4 is 64. So the side length of the carton is going to be 4, and don't forget your unit of measure, 4 feet. Simplify. Now notice this is a proportion because we have 2 fractions that equal to each other. So we use some people call it the Jimmy Neutron, or we just find our cross products and set them equal to each other. So let's start here. 3 times 15. So 3 times 15 equals, and now we do our other cross products. 5 times, I'm going to put this in parentheses because I want to keep that group together, x plus 2. Now we just simplify and solve for x. So this is 45. And now notice we have to distribute 5x plus 10. And now we're trying to solve for x. So I need to get rid of this 10. I'm going to start there. 35 equals 5x. Divide both sides by 5. So we get x equals 7. Number 15, it looks like we're just solving for x, but we have variables on both sides. So remember, the first thing you always want to do is simplify before you start moving things across the equal sign. So notice on this side, we can simplify this distribution. So the left side doesn't change. We still have 15 plus 10x. But I'm going to distribute over here. We have negative 5 times negative 2x. So that gives me a positive 10x. Minus negative 5 times 3 is a negative 15. So really that just becomes plus 15. So now we want our x's all on one side of the equation and everything else on the other side. So I'm going to move my x's all to the left-hand side. So that means I need to move this entire 10x over to the left side. So I'm going to subtract 10x from 10x because that'll cause it to cancel. And then I subtract it from this side too. And notice what happens here. 10x minus 10x, those cancel too. So all I'm left with is 15 on this side equals 15 over here. Now notice 15 does equal 15. So this is an identity. If you had gotten something weird like 8 equals 15, it would be no solution. But in this case, since 15 does equal 15, it's identity. Okay, again, we're just solving for m this time. I'm going to write this a little bit bigger. So we want m by itself, so that means I need to get rid of this -5 and this -3. I'm going to start with the -3, and the opposite is to add it. So we have 10 equals -5m. We're going to divide both sides by -5. So m equals -2. Now on a test, your homework, anytime you do problems like these, it's always a good idea to take your solution and plug it back in to make sure it does work. So let's do that right now. So if we had 7 equals -5 times -2 minus 3, this would give us 10 minus 3, which is 7, equals 7. So we know our answer is right. Number 17, a frame store purchases frames for $12 each and then marks up the price of each by 45%. What is the markup and the new price of each frame? So let's find the markup first. The markup is pretty simple to find. You take the number you're starting with, which is 12, and they marked it up by 45%. So you need to find out what is 45% of 12. So that's a multiplication problem. And remember, we never multiply by percent. We have to turn 45% into a decimal, which is just moving your decimal point 2 times to the left. So we multiply by 0.45. And we should get, let's see, that's 10. $5.40. So that is our markup. And now the new price is we take our original price and we add our markup to it, which will be $17.40. So here's our markup, and here is our new price. So you want to make sure you answer both questions. Number 18, water flows into a swimming pool at a constant speed, as shown in the table below. What is the rate of change? So remember, rate of change is basically just finding slope. So anytime you see time, that's going to be your x. And so volume, that's our y. So you can find the rate of change just like you would find the slope of a line. So notice this is a point here because this is an xy. So there's 312, and then we have 624. I could have chosen any of these 4 points. I just went with the first 2. Now we're going to find the rate of change. So remember, the rate of change is finding the difference in your y's over the difference in your x's. So remember, the y's are your volume in this case over your minutes, because that's your x. So we have 24 minus 12 over 6 minus 3. So that's 12 over 3, which is 4. So that's 4 gallons per minute. Make sure you don't forget to put your label in there too. Because if you just put 4, you're not really sure what you mean there. So you want to say that the water flows 4 gallons per minute. 19. Write in point slope form the equation of a line that has a slope of 3 and passes through 0.28. So point slope form is y minus y1 equals m times x minus x1. So if you remember, we always plug our points into the second y, and the second x. So I'm going to rewrite this as y minus, and then I'm going to take my y value of 8 and plug it in for that y, equals m is always our slope, and they told us the slope is 3, so I plug in 3 there, times x minus, and then I plug in my x value to this second x. And that's it. They just want us to keep it in point slope form, so we keep it like that. And number 20, determine whether the sequence below is an arithmetic sequence. So it goes -7 to -3 to 1 to 5. So if you notice, it goes up 4 each time. So add 4 each time. So yes, it is arithmetic because it's going up by the common difference. So our common difference is +4 because it's going up 4. So our next two terms would be, so we have 5, so if we add 4 to that, it would be 9. And then if we add 4 to that, it would be 13. And that is the last question.